Okay, here we are again, looking still at our biofuels though. The two that we are going to look at is, and I introduced this before, is bioethanol. So here's bioethanol on the board from the last lesson, and here is our biodiesel, again from last lesson. I'll run quickly through the bioethanol again, but we did it previously. So we know that bioethanol, for example, is basically ethanol, but it comes from a plant source through a process of fermentation. So the plant obviously absorbs carbon dioxide and it produces glucose for us. Right? Glucose is a fuel for the plant, obviously. What we do is we extract the plant. In this case, it would be sugarcane, or I can extract it from even any complex carbohydrate. I could take it from honey or potatoes or rice, because it's basically, in the day, it's just alcohol. And so basically we are using a carbohydrate source, in this case a simple sugar, and we're going to carry out fermentation with that sugar to produce the ethanol. Ethanol is the fuel. We burn the ethanol and that produces for us an exothermic reaction. We said before that this is carbon neutral, provided the CO2 we produce is used up again by the plant in photosynthesis. So the biofuel, in this instance of bioethanol, comes from fermentation. That's the main reaction that we're talking about here. And we've spoken before about fermentation. Little compounds, little microorganisms called yeast, chomp away at the glucose, and they produce for us ethanol. In this case, ethanol for fuel, not ethanol for drinking. But bearing in mind that both of them, whether I'm consuming the ethanol, not pure ethanol, of course, because it's pretty toxic, but if you were drinking an alcoholic beverage, it's not much different. So I'm drinking an alcoholic beverage, okay, for example, it becomes the fuel for my body, and it undergoes basically respiration inside the cell once it's transferred into fuel for me. So whether it's me consuming the alcohol, which is very not good, or me burning alcohol in my top fuel dragster as an energy source, then it obviously is producing lots and lots of heat for me. So that's the bioethanol. The biodiesel is a bit more complicated, and I've got to just take you through some basic structures first. So biodiesel is ester of fatty acid with a short chain alcohol. Now, you won't know what any of that is yet because we haven't done organic. So a fatty acid is any carboxylic acid, and the formula for a carboxylic acid is this. That's the general formula. R is a carbon chain. So if the carbon chain is a long carbon chain, then it's defined as being a fatty acid. A short chain alcohol, well, that would be 1, 2 or 3 carbons, and alcohols have got the general formula ROH. So things like methanol, that would be a short alcohol. Ethanol would be a short alcohol, and even propanol would be a short alcohol as well, having 1, 2 or 3 carbons in the chain. So that's the structure of our biodiesel. So the structure of an ester is a combination of both the carboxylic acid and the alcohol, and this is a general formula for an ester. In this case, if it is a long carbon chain, which is what we said, and if it's short alcohol, then that really is the basis for our biodiesel. So the biodiesel structure looks something like that. How you get to it is not very simple though, it's quite a complex reaction. You don't have to know the mechanism, but we'll go through and explain it. So what happens over here is that we take our fat or our oil. Now again, you won't know about the structure for a fat or an oil. When we get to this, these are called they're called triglycerides, and we'll look at fats and oils in topic 3. But this is a triglyceride structure. So essentially it's a long carbon chain of a carboxylic acid. That's the basis of the carboxylic acid there. And it's bonded to glycerol. That's where the name glyceride comes from. Alright, so we've got 3 of these. 3 long carbon chains, and we're saying that this is at least, I think, what is it, 11, where did I put it? Yeah, 11 to 18 carbons long. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up to 18 carbons on these 3 chains. They don't have to be all the same, they can be different lengths. I can have 2 18s, 2 11s, 15, whatever. But the carbon chain has to be of that magnitude. Greater than 11, less than 18 is the biodiesel formula. We react that with ethanol. Ethanol is a short chain alcohol, and we end up with 3 of them. We end up with, if it was 12 and 1, that would be a 13 carbon chain. That means that should really be C11, shouldn't it? 11's along there, not 12. So I've got to make sure that I count that. Let's try it again. 11, that would be C11 there. And obviously I'm using the skeleton structure to do these, but I'm not taking a lot of care. If you did it in the exam, you need to be very specific about the number of carbons. You just can't do it as a squiggly line like I've done. Alright, anyway, back to this. So we've got 1, 2, 3. This is basically my biofuel. So there it is. 12 carbons long with an O and a CH3 on the end. What I've done is, here is a similar structure, okay, combined together. Did I get that right? Just want to check that one. Yeah, so that'll be okay. Okay, so that's my biofuel. But I think we'll have a look in a minute, and if you haven't worked it out already, all right, then this formula has got an error in it. But we'll come back to that one in a minute, all right, for the biofuel. But anyway, so it should have an oxygen there, and it hasn't, all right, in case you haven't worked that one out already. It should have 2 of them, actually, and I reckon there's an error in the formula. All right, so, and there's something for you to work out. So I want you to use that formula, which would be, what would it be? That would be C12H something, and then it would be COOCH3, that reacting with oxygen to produce carbon dioxide and water for the biofuel is what it should have been. I don't know where they got that from, okay? Alright, but anyway, based on their straight hydrocarbon, alright, which is their biodiesel, we are reacting with oxygen, carbon dioxide and water, the products. And so it's the same reaction as the combustion over here that we had for our bioethanol. So all combustion reactions involve reaction with oxygen to produce carbon dioxide, gas and water. Here we are again, reaction with oxygen to produce carbon dioxide, gas and water. If you haven't worked out, obviously diesel produces a hell of a lot more carbon dioxide when it's combusted compared to the same number of moles of a smaller molar mass fuel. And that's part of the reason why diesel's been phased out over the next few years. Not to mention the fact that a lot of the diesel goes through, and coming out the other end, we also get lots of particulate matter, carbon or unburnt diesel fuel. If you look at a diesel truck lately, where all the black smoke comes out, well, that's the carbon that's been unburnt. Some of that's also due to incomplete combustion that we'll talk about later. So, general idea is, what's bioethanol? How do I make it? Using fermentation. And what is biodiesel? How do I make it? Using trans-esterification. What's a biodiesel structure look like? What's a biofuel look like? And of course, we've already done the advantages and disadvantages of biofuels. So that's basically just our intro, or no intro, that's our finish, basically, of those 2 types of biofuels.